Do you remember this game? Well, I'm going to build a fully functional, real-life version of this game because one time I went to play it and it had disappeared from the entire internet. The only way to ensure that that's never going to happen again is to physically build it. But I'm not talking about whatever this thing is. It has to be real 3D parts that move with real mechanisms and real motors. But it's got to be just as fun as the original game. So here are the project rules. 1. It has to include all the elements of the game. The Flappy Bird, the scrolling pipes, a scoring system, sound effects. Rule number 2. It has to play as close to the real game as possible, and we're going to come back to that in a second because rule number 3 is I have to beat Majin Phil. Who's Phil? Phil is a professional gamer and one of my oldest friends, and growing up, I would go to his house to play Super Nintendo and would just end up watching him play because he was already the GOAT at 6 years old. So I've never beaten him in a single game, ever, but I've also never challenged him to a game that I've made. Since the machine doesn't exist yet, the only way to train is to play the actual game. Which brings us back to rule number 2. It needs to have the similar jumping mechanics and randomized pipe positions just like the digital game. I'm not sure what's going to be harder, engineering the machine or beating Phil, but the only way to find out is to start designing. So let's do it. Let's just start simple and make a bird. But first and foremost, I need to determine the scale of the game in the real world, which at this point is completely arbitrary. I'm just going to make it up. So I settled on a pipe this size because it's about as big as I can go on my biggest 3D printer, and we're going to use this to set the scale and build the game around it. I've imported a screenshot from the digital game into SolidWorks and sized it to match the size of the test pipe. The next step is to design a bird about this size relative to the pipe. And the challenge with that is that this bird has only ever existed as a 2D object. So making it into a 3D object, I basically have to make up a third dimension. So welcome to this segment of the video called Doing Things in SolidWorks That You Should Be Doing in Blender Because Blender is Very Hard to Use and you already know how to use SolidWorks. And after spending more time than I'd like to admit playing around with planes and sketches and surface modeling tools, I ended up with this. A bird? A whale? I don't know. But when you print it out and you add these little wings to it, you get a Flappy Bird. So cute, so awesome, but still not even close to done. Like, first of all, it's obviously the wrong color. Also, how is it gonna connect to the machine? How's it gonna jump like in the real game and game overs and stuff? But it's a good start and we're just getting started. But before going further with that, I wanna jump to the scrolling pipes because they're the most crucial functional part of this whole project. And I also think it's gonna be the most fun to design. So there's two main sub-problems we need to solve. First, we need a way to get the pipes to scroll horizontally across the screen. Second, we also need to be able to adjust the pipes to different heights as they are scrolling. For the scrolling, I think I'm going to settle on the chain guide conveyor. These carts are dragged around the rail by the chain, and then I can attach the vertical pipe mechanism thing to the carts. So let's start by seeing if we can even get the chain guide concept to work. The carts need to be able to travel on both the straight sections of the track and the curved sections. And I've printed out a little test track, but I can't just put a basic 4-wheel cart with evenly spaced wheels onto the track. When I try to move the cart onto the curve, it gets stuck, and looking at the CAD, it makes sense. Like, look at this wheel right here. And you might be thinking, hello, trains exist over 200 years now. Check how they do this. Well, to all the people who probably saw this video or this video on YouTube and then decided to share this newfound wisdom with me on my shorts, you already know that train wheels are designed to travel on both straight and curved tracks. You agree that it's obvious that the conical train wheels automatically adjust to the track when going around a turn because the centripetal force pushes the train car outward, which forces the inside wheels to have a smaller diameter than the outside wheels, which naturally causes the train cart to turn. And you completely understand that the simple statement, just use train wheels, looks more like this in the real world. How big are the wheels? How wide is the track? How tall are the rails? What's the radius of the curve? How's the cart going to go together, etc., etc. And when it's all said and done, you're not even impressed because you already knew that it was going to travel on both the straight and curved sections. But among other things, you missed this part. Oh, by the way, I think I figured out the vertical pipe mechanism. We'll get back to that. For the carts, we're taking more of the approach of a roller coaster car, where the wheels lock onto the track, which will deal with the off-center weight. Although in my design, I decided to go with these groovy wheels. So secure. And if I put a pivot in the center of the first demo cart, it travels really well around the track. But I feel like getting the whole pipe attachment thing onto this might be a little bit awkward. So playing around with the wheel positions on the rigid cart in SolidWorks, you can see that when I align the wheels with the straight section of the track and the curved section, I end up with this trapezoidal shape, but should be able to make the transition perfectly. And testing it out in the real world, boom, we have ourselves a cart that moves around the track. Now if we connect the motor through a hex shaft to a sprocket and add a 3D printed chain, when we turn the motor on, and yeah, that's a little slow, let's speed it up. Yeah, that's much better. We have ourselves a proven concept. It is a little bit squeaky, but you know the fix for that. I did test out these rubber wheels as well, and both seem to run with negligible difference, so I think I'm going to stick to the groovy wheels because they're smaller and cheaper, and just like way groovier. It is just running shockingly well. These carts going around the circles, I really wasn't sure if attaching the carts to the chain the way that I did was gonna work, and it seems to be working flawlessly. It's amazing, it feels so good, but it's also scary because the next step is to just scale the entire thing up to the full scale. But it would probably make sense to get the vertical sliding pipe system sorted first, which needs to set the pipes to a specific vertical position before they enter the playing area. To make this happen, we can just slap a motor onto the cart and use a belt to raise and lower the pipes on these steel rods. There's gonna be 14 pipes in total, so I think I'm gonna go with these cheap servos, which are just a motor, a gearbox, position sensor, and some control electronics, all for like $4 a piece. But they only move 180 degrees, which isn't even close to enough. The pipes need to slide a full 300 millimeters. So I'm gonna have to modify the motors to run continuously, which will give us a lot more range of motion, but it will unfortunately remove the position feedback. To regain the position feedback, we can add these bumps onto the back of the pipe, which hits this switch as the pipes move, telling the controller where the pipe is within its range. Actually, scratch that. When the pipe is in the top position, there's a little bit of wiggle, not tons, but enough that it's not triggering the switch. I also need a second switch on each cart so the controller knows where the pipe is at the top and not just at some arbitrary point in the middle. To solve both these problems, let's swap the bumps and switch for this multi-turn potentiometer. As the pipe goes up and down, the potentiometer spits out a value specific to the pipe's location on the slider. So it knows when it's at the top or any other position, basically turning the servo motor, which I converted into a regular continuous motor, back into a servo motor, but like a linear one. This also reduces how many microcontroller inputs I need for each cart from 3 down to 2, which will be useful when I'm wiring the whole thing up later. Great, this is working really well, but of course, with every problem solved, a new challenge is presented. In this case, how do we get power to the motor as the cart is traveling around the track? If I just wire the motor directly, eventually the wires will get twisted and rip out. One idea is to use a slip ring, which allows electrical signals to pass through an axle. If I position it in the center of the rails, it works well enough on the small track, but for the bigger track, it would get a bit awkward with the wires like drooping in the middle. I could definitely use some sort of wire retraction system, or I could probably just power the entire thing with USB power banks. But a big part of doing these projects is I get to push myself to try new things. So I'm gonna try an idea I'm actually really excited about. Taking inspiration from slot car tracks, where the track provides uninterrupted power to the car through the rails on the track, I can add copper tape into the grooves on the track and hook it up to power. On this test cart, I added these 2 pogo pins which press against the copper tape, and when I turn on the power, the LED lights up and continues to stay lit up as the cart's moving on the track. Adding a capacitor to the output stabilizes the voltage and reduces the flicker on the LED, which proves that this concept's actually going to work. But this does look a little too DIY for my liking. Check out this video from Stephen Bennett. He's making his own version of the Dyson sliding lamp, and he got these PCB tracks made so he could get rid of all the wires and the sliding components. I love this idea so much. My tracks are gonna be 680 millimeters wide, so I don't even know if it's possible to get PCBs that big. You know what? Let's just take a look. Looking at PCBWay's website, the max PCB they can make is, oh wow, they can make a PCB that's over 1 meter long. We're good. If I export the track sketches from SolidWorks, I can import them into KiCad and use that as the trace, and then I can use the outline of the tracks to make the PCB cut lines. Then of course you gotta add some Engineezy logos for style, and now I can upload that to PCBWay's website. We can select the sexy black solder mask, sexy gold coating for the traces, which will also make them stronger. And like a week later, look at how these turned out. They were not cheap, and there are definitely more affordable ways to do this, but they are completely continuous and definitely do not look DIY. So thank you to PCBWay for providing me with these incredible marvels of modern engineering, and I don't even know what I'm trying to say here. They're just beautiful. And they fit perfectly into the 3D printed track pieces, which I also outsourced because I went through all the trouble to get continuous PCBs. It would have been a shame to have track sections that were in pieces, and I don't have a machine big enough to print this in-house. For power, I added traces to the bottom of the PCB that connect through vias to the tracks, and I can just solder some wires to them. Finally, we can get the carts onto the track, and you can see that the pogo pins line up perfectly with the traces on the PCB. So nice. Okay, everything is hooked up. The tracks look incredible. But here's kind of the moment of truth, because this is uncharted territory. I've never even done anything close to this before. So if I turn this on, this should go up and down, and if I slide it, it should continue going up and down. So let's just test it out, because final check. Okay, 3, 2, 1. Okay, so that's working. Amazing. Now let's see what happens if we slide this. Yes! That is so sick. Can it go around the curves? Absolutely can. And with that, I think the pipe cart sub-project is mostly done, but instead of jumping into the big scary 14 cart build, let's first tackle the sound effects. Every time you get a point in the game, there's this da-ding sound. I wanted this sound to come from actual chimes, so the plan: use these spring-loaded hammers, which will get pushed into this position, then dropped onto the chime. If I add this ramp to the back of the cart here, position the hammer here, and slide the chime just onto the track like this, as the cart moves past the hammer, it should pull it back and release it. Nice. To get the dud-ding sound, I could just add a second hammer that is slightly longer, and now, I also decided to add this lever that can lift the hammer to turn off the sound. Sweet. I think this satisfies the annoying sound effect rule, but we're still going to keep procrastinating the BSB, big scary build, just a little bit longer, because right now our Flappy Bird is still pretty useless, remember? Getting the bird to jump is a simple at first kind of thing, which ended up being the most complicated mechanism that I've designed maybe to date. When you look at the game, you can see that the bird does single jumps in place, but it can also travel vertically up and down on the screen. The bird also tilts upwards on the jump and then tilts downward once it falls past its original jump point. The vertical travel problem is easy. I could use a belt-driven slider similar to the pipe mechanism, but this time I'm going to control it precisely using a stepper motor. But just controlling the motion of the bird with the stepper motor is a little too digital for my liking. So I added a second free slider, which bounces off the belt-connected slider. Then, if I put the bird on this pivoting counterweight thing, it sort of does the tilting like in the game, and vaguely satisfies the rule. But honestly, this kind of sucks, and I think we can do way better than this. Upon closer inspection of the game, the bird actually only has two states. State 1 is up, state 2 is down, and I couldn't help thinking that there's gotta be a way to do this mechanically. This was the first time I was ever able to actually use AI to help with mechanical design, and before you get too excited or too freaked out, it only sort of pointed me in the right direction. In fact, it literally just suggested I use a bistable spring and kind of left me to figure out the rest on my own. This is the diagram it gave me. Not very useful, but it did get me thinking in the right direction, specifically with this bit right here. A bistable spring has two positions in which it's stable, position 1 and position 2. The spring is at full compression when the lever is in its center position, but when you move it just past center, it snaps into a stable position. This model is available for free on engineeasy.com, by the way. Super fun to play with if you want to print it yourself. So if I turn this thing sideways and I put the bird on the pivoting piece, then we end up with the downward and upward tilt states. To make this happen during a jump, we can put this onto a lever which is activated by the solenoid. If we add a trigger lever here, which moves this slider back and forth, now when the bird jumps up, the trigger lever gets activated by this fixed arm, pulling the slider back, which pivots the bird into its tilting up position. Then on the way back down, the same thing happens but in reverse. And when I combine the mechanism with the solenoid, you can see that it's mostly working. We're gonna have to fine tune this on the full build, but the last thing that the bird needs is a way to signal game over. In the actual game, when the bird hits an object, it falls to the bottom, boom, game over. I think it'd be fun for the bird to actually fall when it's game over. So I added some magnets to the bird's mounting post here, which magnet onto the pivot here, and I added some tiny pogo pins to the pivot, which pressed against this bit of copper tape on the bird, completing the circuit, kind of like closing a switch. When the bird pops off, the circuit gets interrupted, which signifies that it's game over. And just like that, the bird sub-project is almost done as well. Which brings us to the final sub-project, the scoring system. About a year ago, after testing a bunch of no-screen scoring systems for my mechanical platformer game concept, I settled on a split-flap scoreboard. Check out the video if you want to see the deep dive, but since that project kind of died at the cardboard prototype stage, I decided to use the split-flap scoreboard for this project instead. Kind of. Because the plan is to embed the scoreboard into the background of the machine so the score is floating, similar to how it is in the game, but the current flaps are a little bit big, so first I need to shrink them down. I feel like 3 digits is more than enough. I could barely get more than 10 points in the game, so a max count of 999 should be plenty. Maybe Phil will have something to say about that. I doubt it. Speaking of Phil, up to this point, I've tried to keep the advantage by keeping the game a secret from Phil. But then I decided to hop on this call to get in Phil's head, and the first thing I do...
You just gave it away.
Oh, did I just give it away?
I think you did, yeah.
You can say it. You heard me say what
Flappy
I said.
Bird?
Right?
Points?
Have you not played Flappy Bird?
No.
Let's just see how good you are at it right now.
This?
Yeah, this.
Okay, I got it. Okay, I've downloaded the tech.
Okay, let's see. I might have a chance.
I think you might have a chance too.
Well, you have about a month to figure this game out. Oh God, he doesn't even need a month. Oh no. Oh no.
Oh, nice. 9.
Okay, so there's a chance. There is a chance.
I'm excited to flap some birds, bruh.
All right, dude. This was very revealing. Okay, so there may be a chance that I can actually beat Phil at this game. Amazing. But there's still a lot of work to do. And now that we have score, what about high score? In the game, when there's a game over, you end up with an overlay screen that shows the score, as well as the high score and the chance to win a medal. So of course, we're gonna need another 3 split flop displays. I'm thinking that we could have these underneath the main score in the blanked out position until game over. Should we get a little crazy here? I think we're gonna get a little crazy because it would be sick to have like a second screen that reveals itself when you get the game over. Maybe we could have like a door that like pushes back and then reveals the game over screen. Let's do it. This is a sick idea. And how do we do this? I don't know yet, but Dr. Thing does. And he happens to have 3 options for this exact type of thing on his channel. I decided to go with this one because it looks like it's the easiest to implement. First, we need tracks shaped like this. The sliding door has these bearings that glide in the tracks. The whole thing is actuated by this servo motor, also modified to be continuous. The motor drives this pinion which meshes with this rack, sliding the door out of the way. To get the door to sit flush against the backboard, it starts its movement by sliding back from the backboard at the same time as moving sideways. To account for this diagonal motion, the rack slides laterally in the pinion while driving across it. So simple, but very effective. Nice. Like almost everything that looks perfect in CAD but then gets built in the real world, the single motor mechanism did not work. Because it's trying to pull the rack across at the bottom end of this long door, it causes the door to twist a bit, which sort of jams. My first attempt at solving this problem was to add a second motor at the top, which evens out the force on the door and removes the twist, but it's very hard to get these continuous servos to synchronize well, which also causes jamming. Instead of switching to more precise stepper motors, which would require more electronics, I decided to swap out the second motor for this belt drive system that will use the belt to sync up the motion of the 2 racks. But of course, I messed up the first time, because in this configuration, the pulleys rotate in the same direction, but I need them to rotate in opposite directions. And I knew this, but I didn't catch my mistake before building the entire thing. But as you will see moving forward, the theme of this project becomes, it's not about how you mess up, it's about how you recover. To solve the problem, I just need to move the pulley up, add a gear to it, which meshes with another gear, which meshes with the rack. Pretty much everything else stays the same, and now the door works amazingly well. And that concludes this side quest tangent that was 100% worth doing, because look at how sick this door is. Alright, now that that's done, I think that I really just can't be procrastinating the big scary build any longer, so let's get it done. Okay, fine, I can procrastinate a little bit longer, but this is actually productive procrastination. I have to get better at the game so I don't lose to Phil. Remember, rule number 3, arguably the most important rule of the project? And yeah, the practice has been paying off, because look at this. I don't know if you can see this very clearly, Phil, but that's a 4 in front of the 0. That is 40 points. Watch out, I'm coming for you. It is absolutely insane the total amount of individual parts that ended up in this build. There are over 1,000 individual parts, many of them 3D printed. I printed the pipes in this green filament, and if it's weird for you to see colors other than white on my machines, it's weird for me too. I'm branching out, I'm growing. I don't know about you, but I find harvesting prints to be a pain in the butt, which is funny because 10 years ago it was crazy to even dream about having machines this good. And as much as I love seeing my visions come to life, I really dislike repetitive, tedious assembly jobs. I guess I didn't need to choose 14 total carts for this machine. We could have had a perfectly good Flappy Bird game with like 10 total pipes, but it's like when you're hungry and you order more food than you can eat. The engineer in me ordered way too many carts, so I got my dad to come and help me build them. Don't act, just do.
I'm going to do. You tell me when to go.
Go.
Oh.
That was anticlimactic. All right, nice work. I decided to use aluminum extrusions for the frame of the machine. This stuff is incredible. But here's me realizing that once again, I've designed a project that won't fit in my shop. I can't seem to stop doing that, so I think it might be time to find a new shop. In the meantime, I shortened the frame to make my life a little bit easier, and I can extend it later. The more projects I build, the more I realize that engineering is just a big order of operation planning exercise. It's one thing to conceptually understand how a mechanism will work in your design, but the real engineering happens when you start thinking about how you're actually going to build the whole thing. I finished a lot of projects up to this point, and it's still hard, but I'm finding that I'm starting to catch things in the design process that make my life easier in the build process. Like these slots in the bottom of the carts that make it easier to slide the whole screw groovy wheel spacer stack into place before screwing it in. Or the mounting holes for the electronics, that's a big one. Or especially these clips that I can use to contain the wires. Thinking about wires is finally becoming a little bit more palatable for this old mechanical engineer. So the first cart is on the track, but right off the bat I can see that I'm getting a lot more wiggle than I originally had in the versions that I was testing. I think maybe this outsourced track is just worse tolerance, and it doesn't look amazing, but I didn't think it'd be this bad. Hopefully, when all the carts are on this thing, like the chain dragging them all around will reduce the wiggle. Let's just put them all on and see. Okay, the chain is surprisingly like perfect tension. So I guess it's time to see if we can actually even move this thing. I've never seen all of these things move together. So we're gonna do it together for the first time. I'm gonna try to move it from the sprockets down here. Oh, wow. Okay. That's actually not bad at all. I actually think we can get this to move with a single motor. Okay, give me a second. Motor is plugged in. 3, 2, 1. Oh, I think it's just a motor tension issue. Okay, wait. So anticlimactic. 1 hour later. Got both motors hooked up. So, here we go now. Okay. Good smooth movement. The one that I was like most concerned about is actually like the worst one out of all of them, and it seems to be completely fine. So this is good news because this is officially like done now. Wow, that's that feels good. I mean, like we're not even close to finish this thing, but this is working, which is amazing because this is probably like the biggest. I mean, I can't even say that honestly. This whole project has ended up being hard. This was the part that I thought was going to be the hardest. It's done, it's working. There's other hard parts that we need to finish. Like building the entire lower pipe assembly. Have I mentioned how much I love repetitive building tasks yet? It wasn't so bad, just got the music going and found some flow. Honestly, it's kind of nice, meditative. But now that it's done, I have to extend the frame of the machine. And then there was this awkward assembly step, which would have been easy peasy if I wasn't working in a dungeon with 6.5 foot ceilings. Have I mentioned that I need a new shop? But it was pretty smooth sailing from that point on, and there's really nothing more you can ask for on the first ever build of a project this complicated. One of the more tricky design decisions I had to make was how to attach the door assembly to the front plate. I need everything to go in very exact places, so gluing it might be tricky, but I want there to be a clean, uniform finish to it. I decided to laser cut holes into the plate, which I made in 2 pieces because I was too lazy to hook up the pass-through system, and then I used this counterbore bit to recess the holes on the front. The flat screw in the recessed hole is so satisfying. Then I can screw everything in from the front to the back, and I'll cover it up later. This is a little sketchy because if I need to change or fix something, I'll have to remove whatever cover I decide on. Right now, my overconfidence or ignorance is saying that I won't have to worry about that. The engineering guys are definitely laughing at me for that. Remember the updated project theme from earlier? It's not how you mess up, it's how you recover. Well, here's where that starts to become a bit more true. I used a thinner front plate than I originally planned to make room for the new bird jump mechanism. And when I went to tension the belt for the unnecessary but cool sliding door, instead of the belt getting tensioned, the plate just flexed. To fix, this steel rod and adapters. Just unscrew this, chuck this in here, screw it back in, drill new holes here, screw it into place, tension the belt, bada bing, bada boom, problem solved. Next, the unnecessary but cool door is interfering with the chime system. Easy, just saw the chimes in half, so they have a lower profile. Don't worry, they still work. and then reinstall them. Problem solved. Next, the motor for the unnecessary but cool door is preventing me from sliding the front plate into place as I planned. Easy, just cut these parts off with a side cutter. Don't worry, I was using state-of-the-art safety squints for eye protection here, and then pop the front plate in this way instead. Finally, the time has come to start coating everything, and I'll give you a run through of everything when I understand it better later, because right now, this is kind of how I feel about all of it. Also, remember when I said that the bird jumper works, kind of? Well, no matter what I tried, I couldn't get the solenoid to work the way I wanted it to. There are some physical limitations in the solenoid that make it so it's really hard to program it in a way that resembles the Flappy Bird jumping animation. Also, it was getting really hot and the plunger kept popping at the back. So I bit the bullet and redesigned the entire mechanism to work with the servo motor instead, which required a complete disassembly of the slider system, pulling the wires from the drag chain, which took me like 45 minutes to get in there, and then reassembly. But it works so much better now. One key thing I'd forgotten was a feedback system that tells the controller which cart is where on the track, which is important for setting the positions of the pipe. I realized that the solution was actually quite simple. I just need to add these magnet holsters to the sides of the carts. The holes here were just insurance holes for when I inevitably needed to add something that I had forgotten. Insurance holes for the win. Each cart has a unique combination of 1 to 3 magnets. Then if I add this array of magnet sensors here, now when a cart goes by, it can detect that a cart has passed by and specifically which cart it is. Dope. The last thing I needed to do was apply a stupid amount of glue stick to the front panel and full commit to gluing it onto the graphics that cost way more to get printed than I was expecting. Contrary to popular belief, I can lift this 5-pound dumbbell, and I don't keep it in my shop to get a quick workout in. It's for situations like this where I need to apply some weight to something. After letting it dry and trimming out the holes, I quickly forgot about the printing cost because this is looking so sick. And it looks even better when it's installed on the machine. Finally, I can add in the split flap scoring system, making sure to rip out a couple of wires from other places on the way in, and then we can call this a build. Oh, by the way, remember when I said I needed a new shop? So I'm in the process of not sleeping for the past 5 months because we had a baby, and building the most complicated project to date, and working super hard on my Flappy Bird skills. I got myself a new shop. Welcome to the all-new Engineezy HQ. Obviously, I haven't really moved anything in yet, but I'll never have to worry about knocking anything into the ceiling ever again. Yes. Also, there's so much more room for a celebration when I kick Phil's butt in the showdown. All right, let's take a closer look at how the electronics and code works on this thing. So, starting with the pipe systems, we have 3 carts connected to this controller and 4 carts on this one. They interface through these boards that I designed for this project, and they get their 5 volts through their connection to the track. I swapped from pogo pins to these brush things to preserve the traces on the ring PCB. I also added these big capacitors to even out the voltage ripples caused by this whole get your power from the tracks thing. The top and bottom cart systems are synchronized by these hexagonal shafts, which are driven through belts by these 4 stepper motors. They're all connected to this controller, and I just want to take a second to shout out my buddy Andrew from OK Design for helping me out with the PCB design on these things. This PCB would have far exceeded my capabilities, but it was honestly really basic stuff for him. They've designed a bunch of really cool mechatronic art projects like this 80 ball kinetic sculpture, and I know they're working on something else that's really cool, so give them a follow if you want to be blown away. For the bird jumper, I'm using this board that I designed myself with Andrew's help, and it takes the input from this arcade button and synchronizes the stepper motor and the servo motor to make the bird's jumping animation work. Each split flap module is running on the same custom board and drives the stepper motor a specific number of steps depending on which number it needs to show, as called for by the master controller. This talks to each of the controllers over a wireless protocol called ESP Now. It keeps track of the score, watches for the cart sensors and sends randomized pipe positions, monitors the bird sensor, and determines which state we're in, which is either idle, waiting for you, in gameplay, or in the game over state. It's also responsible for opening and closing the sliding door, and it was supposed to run the metal slider as well, but I came up with a much better idea. This is a real life video game, so it only makes sense that you get real life prizes when you win, right? A real life coin dispenser. So now if you hit a score of over 10, you get a bronze. A score of over 20 gets a silver, over 30 gets a gold, and over 40 gets this really dope metallic purple coin. I love this. I feel like this was the finishing touch that this project needed. All right, Phil is on his way here. But while we're waiting, I would like to thank this video's sponsor, which is brilliant.org. To get to this point in the project, it required the entire range of my engineering toolbox, and I've built that over many, many years by maintaining a practice of trying to learn something new every single day. One way that you can learn something new every single day is by using Brilliant. Brilliant has a range of courses that can get you moving on a multidisciplinary project like this one, like circuits, digital circuits, and programming courses. But just having access to the courses won't make you learn. It's all about building the habit. And Brilliant is set up to get you smarter in minutes a day. Just swap 5 minutes of mindless scrolling for 5 minutes of learning with Brilliant, and you're gonna be getting those brain gains real quick. If you're worried about being bored, Brilliant has found a way to make learning like actually fun. Each lesson is filled with hands-on problem solving that lets you play with concepts, with a perfect mix of engaging problems, competitive features, and daily encouragement that will keep you motivated and on track. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/engineeasy, scan this QR code, or hit the link in the description below, which will also get you 20% off your first entire full year of Brilliant. One thing that Brilliant can't do is guarantee that I'm gonna beat Phil in this showdown, but the machine's ready. I've been training, I've been practicing my celebration dances, so all that's left to do is win. Let's do it.
Wow. Wow, this is crazy. Oh, you can win tokens.
Yes.
Okay.
That's the button, the jump button. To start the game, take the bird, pop it there.
Bruh, that is so crazy.
Now you have control, and if you tap once, you get a single jump. And to get the bird to move up and down the screens, you tap quickly or release. Game over.
That's crazy.
High score is now 2.
Oh wow, it even updates that? That's nuts.
Here's the rules. Cumulative score, 5 rounds. Whoever has the highest score after 5 rounds takes home the big prize. But there's like a little bit of a side quest. So we have the medals distributor. You get 40 points or more.
Get the purple one.
You get the sick purple one.
Ooh, I want the purple one.
Yeah, I know. Okay, rock, paper, scissors, see who goes first. Rock, paper, scissors, shoot.
Yeah, you got me. Okay.
Although I don't know if I want to go first.
Okay.
All right, we're going it. We're doing it.
Bro, he lied.
Whoa!
You just got pipe blocked.
3.
All right, let's go. How did that not work? 10 on round 1? Thank you. Yes.
It's 10-3, Phil, after round 1. Here we go. Locking in, Phil.
Oh, he's cooking. I'm screwed. Holy cow. He said he'd practice, but he actually played all night.
Oh! Locking, oh.
22.
Oh yeah, look at that.
You got a huge score there.
Oh, you're just topping it a little bit.
Oh, I needed 15 there.
It's 25-20 after round 2. Let's go round 3.
Oh, 7.
Get up.
Oh, my thumb! No, it died! The bird quit on me, bro. Man, the bird got tired of flying though.
It's because you just lost so bad there. It's gotta be a big one. I'm actually a little bit nervous, I gotta say.
Oh, oh man.
No!
he's
No!
Sipping hard on that choke 0.
Ah! Okay.
Your forehead.
I didn't play.
What are you gonna do on stream tonight?
Oh, dude.
It's serious now.
13. I didn't even high score there.
It's the final round.
47 to 39. Or 38. So you need 9 to tie.
9 to tie, and
And then
just
anything, just go nuts.
40 to dummy Phil and to get my purple token. You and me, big guy. Let's go.
Oh my god, he got 10. So I need 1 point to tie, 2 points to win. Okay.
So yeah, key is like you just don't mess up that very first one, you know? You don't want to mess up that one right there. Oh, no.
Oh no, now I'm gonna go for a purple.
Okay, now I'm on your team. Go for the purple. I want,
Oh, I just didn't even, I choked it.
5.
5.
You didn't even take me by that much.
No.
I kind of ran out of time.
What
The
is
print
that?
failed, and so this is what we ended up with. Phil, I am really just like not even like happy at all to be presenting this prize to you, but you are now the proud recipient
Of the bird's nest.
of the bird's nest.
But we gotta get to 40.
2 hours later. Let's go!
Let's go!
Yes, Phil!
I don't care. Oh. Yes! On the back. Like victory.
Show him your hardware.
Got the full collection.
Majin Phil came in, did exactly what I was hoping he would do. He set the high score at 43. If you think you can beat that, let me know.
I was gonna say, I'll fly you out here to try. No, I'm just kidding.
We don't make that much money on this channel.
Go subscribe to Jay.
Subscribe to Majin Phil. I'll see you in the next video.